Question 6. Okay, figure 6.1 show two reactions of the ethanedioic acid. Okay, so the first reaction is with the SOCl2. So from here we know that the SOCl2 is used to substitute the OH in the COOH group. So means the OH in the carboxylic acid will substitute by the chlorine from the SOCl2. So eventually it will form this diacyl chloride. Okay, so this one is easy. Therefore, you just put the COCl and COCl. And the second reaction is form CO2 and H2O. So this carboxylic acid, so now it's undergo oxidation and it's formed this CO2 and H2O. Okay, later we will discuss about that. Part A1, draw the organic product G. So already did, right? So and another one, identify the different reagents that also reacts with this ethanedioic acid to produce the G. We can use the PCl5, and another one is PCl3. In mark scheme, it's just PCl3. In syllabus, actually, is needed when we use PCl3 must with heat. So this part you have to be careful. Part B, identify two different reagents that oxidize the ethanedioic acid to form the CO2 and water. So the standard oxidizing agent used for this carboxylic acid or this ethanedioic acid oxidation is the KMnO4. Must put acidified KMnO4. Other than that, actually we can just burn it, means oxidize it using oxygen. So then it will just complete oxidize and form CO2H2O, right? So means another oxidizing agent is oxygen. Okay, part C. Now we have the same dicarboxylic acid. Ethanedioic acid ionized follow this. So this is just one ionization. And this dicarboxylic acid is much stronger acid than the ordinary carboxylic acid like methanoic acid. Why? So first, you can focus on this carboxylic acid itself before it's dissociate. So and you must relate to the electron withdrawing group. So we know that in this dicarboxylic acid, there are two carbonyl groups there. So the carbonyl groups is electron withdrawing. So it will pull electrons toward themselves. And the electrons in the OH bond, therefore, is get lesser. Lesser means the bond will get weakened. Get weakened means easily release the H+. So that's why H+, now the amount is more, then is more acidic. That's the first reason. Or you can discuss the anion. Once it's dissociate, it will form this anion and this hydrogen ion. Again, because these carbonyl groups, they are electron withdrawing, so it will let these the electrons on the oxygen here, this anion is less available. When these electrons or this lone pair is less available, then it's less likely to bond with H+. Means the H+ concentration is higher. So therefore, the first one, you can explain like this. Because the carbonyl, they are electron withdrawing group, okay, which will weaken the OH bond that I told you, and it will produce more H+. Or you can say that these electron withdrawing groups stabilize the anion. Stabilize means is let this lone pair less available and is less likely to react with H+, more stable. So less reactive, and therefore the H+ amount or concentration is higher, then it's more acidic. This is a stabilization or stabilize means. Okay, part D. Benzene 1,4-dicarboxylic acid, this one, the last one, can be made from the benzene in 2 steps. So this one is quite clear. we need to do alkylation first. Means we need to add alkyl group into the benzene ring. So how? First, we must use the haloalkane. We just use the chloromethane. We no need to use a longer hydrocarbon chain. So use the chloromethane together with the catalyst, aluminum chloride. So the catalyst will get one chlorine or the chloride from the this haloalkane, and eventually it will form this carbocation. So then the catalyst, now it will form this AlCl4 negative. So the carbocations that produce will attack the this benzene ring in the, let's say, in 1,4 position. Actually it's step by step. First it will form methyl benzene, then the methyl benzene will direct the another substitution, another position, the 4th position. So it's actually one by one. Let's say after this, then this will form the methyl benzene. So the methyl benzene will direct another substitutions at the 4th position there. Okay, then you just suggest, because it's the part 1, suggest the identity of J by drawing its structure. So you just put this structure, benzene ring with 2 methyl group, 1,4 position. Okay, after that, now part 2, identify the reagents and conditions for step 1 and step 2. Step 1 is easy, I told you already. We just use the reagent, which is the chloromethane, and the catalyst, AlCl3. Then it will form the carbocation. Okay, step 2 is what? Step 2, after it's formed this alkyl benzene, so this alkyl group need to be oxidized. So the standard answer, of course, in the marking scheme is hot alkaline KMnO4. But if follow the syllabus, hot alkaline KMnO4, it must follow by acid solution. Why? Because when we use a hot alkaline KMnO4, this alkyl group returns to the carboxylic first, and then need to add acid to protonize it, or to add the hydrogens to this salt to form this carboxylic acid. So therefore, the better answer actually is followed by this acid solution. Part 3. Draw the structure of exactly 1 repeat unit of the polymer form when the benzene 1,4 dicarboxylic acid reacts with ethane 1,2-diol. Okay, this one. You must show the linkage and must be full display. I show you this part. Okay, this part you no need to draw. You only draw this part, this one. So this is what you need to draw. Okay, now the carboxylic acid group and this alcohol group, of course, they will react and undergo condensation. So the OH from the COOH, okay, will remove together with the hydrogens from the alcohol. Right here, see the dotted line there? Then the new CO bonds will form here. This is the ester linkage. So to draw the 1 repeat unit, so first you need to remove this OH and remove the H here. Remove the H here. So you put the tails on this carbonyl carbon and 1 tails on the oxygen, and you must show this ester linkage. So this is 1 repeat unit of this condensation polymer. Okay, part 4. State the type of polymerization that occur when this benzene 1,4 dicarboxylic acid react with ethane 1,2-diol. Is very easy. It's a condensation. It's the carboxylic acid and alcohol reaction, and the linkage is ester. This one. Okay, that's all. Thank you.